Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now today we are going to discuss about isometric projections of the square prism and the isometric projections of the rectangular prism, and the projections of these two prisms, that is square prism and the rectangular prism, we are going to discuss in the three orientations, that is horizontal face orientation, left side vertical face orientation, and the right side vertical face orientation. So in the horizontal face orientation, so we will assume that the prism is resting onto the ground on its base, and the height of the prism will be shown along the y-axis over there, right? So this is the y-axis, and we are going to draw the base of the prism in the xz plane over there. So in the xz plane, the base will be drawn and the height will be drawn on the y-axis over there. Then in the left side vertical facing prism, we are going to discuss that the basic plane shape of this prism, it will be drawn in the xy plane, that is between this x and y plane. The basic plane shape of the prism will be drawn, and this length of the prism will be shown along the z-axis over there. So this is the z-axis which is going to show the length of the prism, whereas in the third case, that is the right side vertical face, so the plane shape of the prism will be shown along the yz axis, that is between this plane yz, and here you are going to get the plane shape, whether it is a square or a rectangle, and the length of the prism will be shown along the x-axis over there. So here this is the plane shape, which is a square or a rectangle. This will be shown along the yz plane over there, and the x-axis is going to represent the length of the prism over there, right? So this way we are going to discuss 6 cases. So 3 orientations for the square prism and the 3 orientations for the rectangular prism we are going to discuss in today's lecture. So let us start with the first orientation, that is the horizontal face orientation. So in the horizontal face orientation, we can see the base of this prism will be assumed to be lying on the ground. So on the ground means that is on the xz plane. We are going to draw this base of the prism, and then the height will be drawn along the y-axis over there. Okay, so first of all, we can divide this prism into again 2 halves, that is we can draw the square base in the horizontal face orientation, and then we are going to project it to obtain the square prism. So the first part we have got, draw the isometric projections of a square of side 40 millimeter. So here we have a square for h equal to 40 millimeter. We are going to start with construction of the isometric scale. So the true scale will be drawn at an angle of 45 degree, and the isometric scale will be drawn at an angle of 30 degree. So all the dimensions from the true scale, they have to be transferred onto the isometric scale, and then the isometric projections we can draw. So now the horizontal ground line we have drawn over here, and then the x and z axis of the isometric we are going to draw using an angle of 30 degree from the starting point. So this is our starting point. So from this point we draw the x-axis at an angle of 30 degree, then we draw the z-axis at an angle of 30 degree. Now we have to have the construction of the square base. So here we are going to mark 40 millimeter along the x direction, and 40 millimeter isometric we are going to mark along the z direction, and then 2 isometric lines parallel to the isometric axis, they will be completing the construction of the projection of the base in the horizontal face. So please check, here we have got, you see 40 millimeter we have marked over here, That is, this is the edge length of the square base. This is the 40 millimeter, right? Then 40 millimeter onto the other side. Once again, it has been marked towards the z-axis direction. And then two isometric lines of corresponding to the two edges of the base, they have been drawn to complete the construction of the isometric projections of a square having side or the edge equal to 40 millimeter. Now, we have not darkened all these lines because few of the edges in case of square prism, they will be lying behind these two surfaces. You can see even in the solid we have drawn few dotted lines, but in isometric projections we are not going to draw any dotted lines. So that's why these two edges we have shown to begin with in a lighter or the thinner construction line over here, right? So we have completed the construction of the base. Now you see, let us read out the statement. That is, we have worked out the axis point, work out the center point of this edge, work out the center point of this edge. So the axis line can be drawn over here. This is my center line. Similarly, work out the bisector or midpoint of this edge, work out the bisector of this edge. So once again, the center line has been completed onto the base. So this will give me the axis of the square prism, right? Now let us read out the statement corresponding to the square prism. So draw the isometric projections of a square prism of base edge 40 millimeters. We have already drawn the base edge 40 millimeter, right? And the axis height is equal to 60 millimeter, and this prism is resting on its base on the ground. That is, it is standing upright from the ground over there. Now we have drawn the base. Then now we need to draw the height of this prism in the y direction. So here you see, from here, this point, and this point. So these are three edges for which the vertical edges of the square prism, they will be visible to the observer. So from the first edge, that is this corner, we have drawn the isometric height of 60 millimeter. Similarly, from the other two corners also, this corner and this corner, we are going to draw two more vertical edges, that is the longer edges of this particular square prism, right? So these edges, they are called longer edges. So these edges, they are called longer edges of the prism. So three longer edges, they are visible to us. So we have constructed all the three edges, and the top face, which happens to be a square, so this top face will be visible to the observer. So there will be no hidden line over here. So we are going to draw all the four, you see, edges of the square on the top face of the square prism. All will be drawn darkened over there, that is using the object line. And how we have drawn all these, this edge will be parallel to the isometric axis, this edge will again be parallel to the isometric axis. Similarly, this edge and this edge, which corresponds to the top face of the square prism, both of these edges, they will be parallel to the isometric axis, that is the x-axis, right? So we have completed the top face, which has been darkened as well using the object lines. The vertical edges, they are visible to us, so we have darkened them. Now these two edges of the base, they are not visible to the observer, so we are not going to darken them. But this edge and this edge, so they correspond to these two edges of the base over here, right? So these two edges, again we are going to darken, this one and this one, right? So after completing the construction of a square prism which is standing tall, which is standing upright on the ground, and it is resting on its square base, now we have to find out the axis. So you see, similarly, corresponding to the top face, get the bisector of this edge, get the bisector of this edge, so the center line can be drawn. Similarly, get the bisector of these two edges, so 2 points will be obtained, and again the center line can be drawn. So this gives me the axis point of the square prism which is lying at the top. This gives me the axis point of the prism which is lying at the base or the bottom over there. Now I can join this axis line, right? So this is the axis line which I have joined over there. So this completes the construction of the isometric projections of the square prism, which is lying in the horizontal face position, that is, which is lying on its base on the ground, and it is standing tall upright onto the ground. And another line you see we can join over here, that is this one, this vertical edge which is joining this point and this point. So again a lighter line, just it is for your understanding that all the edges they have been joined, we have drawn this. Otherwise, even if we remove this, you see, lighter line, even if we remove this lighter line or this lighter line, it will not make any difference over there, right? So these are those lines which were drawing hidden even in the projections of the solid over there. But over here no dotted lines are to be drawn. So that is why these edges, you see this edge, we have drawn with a lighter construction line over here, so that you can have the complete feel of all the edges of the square prism, right? So this is the first orientation. Now let us work out the second orientation. Now in the second orientation, you see we have got the prism which has to be drawn onto the isometric projections using the left hand vertical face orientation. In the left hand vertical face orientation, we are going to draw this plane figure. This plane shape of the prism will be drawn on the XY plane over there of the isometric axis over there, and the length will be shown along the Z axis, right? So we have to start with this plane shape. So first of all, we are going to draw this plane shape of the square on the left hand vertical face. So we are given that draw the isometric projections of a square having edge equal to 40 millimeter. Now we have to draw both of the edges onto the X and Y planes over there, X and Y axis. So please see, this is my X axis and this is my Z axis, and here my Y axis will be coming. And first of all, we have drawn the ground horizontal line, then X and Z axis we have drawn at an angle of 30 degree, Y axis will be drawn at an angle of 90 degree to the ground, right? So let us start with the construction of the square facing the left side, right? So facing left orientation. Now here 40 millimeter has been marked. Once again, the isometric length of 40 millimeter has been marked corresponding to one edge of the side face. So this side face will be contained between, as I have explained to you, between X axis and the Y axis, because this square is, or the prism is, left facing. Okay, so now this is 40 millimeter drawn on the X axis, this is 40 millimeter drawn on the Y axis, and now two more isometric lines will be drawn parallel to the isometric axis to complete the side face of this particular square, right? So you can see this isometric line or the edge of the face of this particular prism, this is drawn parallel to the edge which is lying on the isometric axis, that is the X axis. Similarly, this edge has been drawn parallel to this edge which is lying on the isometric axis. So all the four edges, they are equal to 40 millimeter. You see, we have marked 40 millimeter over there. Now having drawn this square face which is being observed from the left hand side, now we can even work out the axis point. So get the midpoints of all the four edges, and then you join these two midpoints, you will be getting the center line. Then you join these two midpoints of these two edges, so another center line will be there. So this is going to give me the axis point of this particular face of the square prism, right? Now let us work out the dimensions of the prism. So we are required to draw the isometric projections of a square prism having side of the square equal to 40 millimeter. So this side we have drawn, and the axis length is equal to 60 millimeter. That is, this length of the prism I have to draw as 60 millimeter, and this will be drawn along Z axis over there, right? So it is resting on the rectangular face on the ground. So this prism is going to rest on the one of its rectangular faces onto the ground. Now I can draw the length of this prism in the z direction now. So please check, I have measured 60 millimeter using the isometric scale, and once I measure the 60 millimeter, so this 60 millimeter length of this prism, you can see this is the length of the prism which has been drawn along the z axis. Now I can mark the 60 millimeter, then another isometric length corresponding to this edge of the top face of this particular square prism can be drawn, right? So now my top face will not be square, this will be the rectangular face which I am going to get. So this edge will be parallel to the isometric axis. So this is my isometric line. Then again I am going to draw these two edges of the top face over there. So this edge and this edge, they are parallel to the isometric axis, right? And then similarly this edge and this edge, they are again parallel to the isometric y axis over there, and this edge and this edge, they are parallel to the isometric z axis. So this completes the construction of the square prism which is resting on its base. But you see, looking at this, I cannot identify where the base is lying. So even if these lines, these edges, they are not visible to me because these edges of the square prism have been covered by this face, left side facing face, then right side facing face, and the top face over there. So these three faces of the prism, they are going to cover these three edges, but in fact they are existing. So I need to draw these three edges with light construction line so that we can have the feel of the actual all the edges of this particular square prism. So you see, from this corner I can draw this length which is equal to 40 millimeter, and this edge will be parallel to these three edges which have already been drawn. Similarly, this edge will be again parallel to the z axis, and another one, this edge will be now parallel to the x axis of the isometric scale. Now you can see we can have the appropriate view of all the edges over there, but since these three edges, they are not visible, so they have not been darkened over there. So only the construction representative lines have been drawn to complete this construction. Similarly, now the axis corresponding to the back face, this is my front face, so this is the back face of the square prism, and the corresponding to the back face, the center point has been located, and now I can join the axis over here. So this completes the construction of a square prism which is lying in the left hand vertical face orientation. So my front view will be this will be my side view, and this will be my top view of the square prism. Now moving on to the third case, that is right hand vertical face construction of a square prism. So here you can check, our square face or the plane figure will be located along the YZ plane over there. Okay, so how we are going to complete? So first of all, once again, we are going to complete the square shape construction on the right hand side, so that we are going to look from the right side over there. So ground we have constructed, horizontal ground line, then this is my x-axis, this is my z-axis, and my y-axis will be lying over here. So on to z-axis, please check, I have drawn 40 millimeter isometric length of the square face. Then on to the y-axis, again I need to complete 40 millimeter, which is the height of the square face over there. This is the height of the square face, right? So once I draw both of these edges onto the isometric axis, so another couple of isometric lines are to be drawn parallel to these isometric axes so that the construction of the square face is completed. So this edge is again 40 millimeter parallel to the isometric axis. Similarly, this edge, it is again parallel to the isometric z axis over here. So this square face has been completed, which is, you see, visible from the right hand side. Now my front view will be this. So once I am looking from this side, So my construction of the square shape has been completed. So this will be one of the faces of the square prism. Now we have to complete the isometric projections of a square prism having edge 40 millimeter and axis length 60 millimeter. Now this length will be drawn along the x-axis. Now let me draw it. So the center point has been located as usual. So this is my 60 millimeter length of this particular prism. So this has been drawn on the isometric axis, which is the x-axis. Now parallel to this, again edges I need to draw over here and over here, so that this top face of the square prism can be completed. And as usual, the top face will be visible to me 100%. So all the four edges of the top face, they are visible to the observer. So I have completed this top face over here. So please check, this edge, they are parallel to the z-axis. This edge, and this edge, they are parallel to the x-axis. Similarly, this one, they are parallel to the y-axis over there. So with this, we have completed the construction of the square prism, but we are not able to show the few edges which are not visible over here. So let us complete those edges also which are not visible, which have been covered by these three faces, right? So let me draw one more edge corresponding to the back face over there. This is the back face of this particular square prism. So this edge will again be parallel to the z-axis, and the length of this edge will be 40 millimeter. Similarly, this edge, that is the vertical edge, this is again parallel to the y-axis, and the length is again 40 millimeter. So this completes my back face. Now I need to join this corner point with this corner point, so that the edge at the back is also located. Now these are the three edges which are going to give us the complete feel of the square prism. That is, all the edges of the square prism, they have been drawn, right? So even though they are not required, but still we have completed all the elements of the square prism. Now the center for the square prism back surface has been located, and then once we join this axis point with this axis point, so this will lead to the completion of the axis also, right? So this completes the discussion regarding the isometric projections of the square prism in all the three orientations. Now we are going to start with the isometric projections of rectangular prism, right? So we are going to start with the isometric projections of rectangular prism again in the three orientation. So the difference between rectangular prism and the square prism is only change in the dimension. In square, all the four edges of the base, they were equal. In rectangular prism, they will be unequal over there. So here you are going to get one edge of the base will be 50, another edge of the base will be 40. So let us start working out the projections in the horizontal face, that is vertically upright. So here we have a rectangular prism, base edges, they are 50 millimeter and 40 millimeter. Prism is resting onto the ground in the upright position, and the height of the prism is given to us as 70 millimeter. So in the horizontal face, once again, x and z axis I will be drawing first, because this face will be contained by xz plane, right? So onto x plane, x axis 50 millimeter will be drawn, and onto z axis 40 millimeter edge of the square will of this rectangle will be drawn. So please check, on the x axis we have drawn the longer dimension, so this will be 50 millimeter, and on the z axis we have marked 40 millimeter, which will correspond to the smaller side of this rectangle. So the base of the rectangle has been completed. Now we know that the height of the rectangle is how much? 70 millimeter. So from the y axis I can draw the height of this prism equal to 70 millimeter. So this is the height of the prism, rectangular prism, okay? So now the height corresponding to these 2 points, it also needs to be drawn. So one point we have drawn, one edge we have drawn, vertical edge representing the height. So now this is the second vertical edge, longer edge, and here we get the third longer edge. So once you draw the three longer edges, so the three longer edges, you can see they have all been drawn dark over here, because these edges, they are visible to the observer over there, and they will be drawn by using the object line, and the top face, it is always visible to the observer. So now we are going to draw the isometric lines from here, and from here. So the three isometric lines we are going to draw to complete the top rectangular face of this rectangular prism. So this is the top face, where this edge of 50 millimeter and this edge of 50 millimeter, they are parallel to the isometric length which we had drawn onto the isometric x-axis, this one. Similarly, this edge and this edge, they are parallel to the isometric z-axis, and the edge which was drawn equal to 40 millimeter over here. So this length happens to be 40, this edge happens to be 50 millimeter, right? So now let us find out which are the edges that are visible. So these are the remaining two edges of the base which are visible to the observer, but this edge and this edge, they are not visible to the observer. Similarly, one edge we have not shown, joining this point and this point. Okay, so this also we can join over there. So please check, we have joined the third vertical edge, fourth vertical edge over here. So now you see the construction of the rectangular prism is completed, and even the edges which are not visible otherwise, they have been shown just to have a feel of this particular rectangular prism. And the center points of the top face and the bottom face, they have also been located. So once we join them, we are going to get the axis of this rectangular prism. So this is the discussion about the isometric projections of the rectangular prism, which is resting on its base on the ground, and it is standing tall and standing upright. So axis is 90 degree to the base over there. Now let us start with the second orientation. So the second orientation is left facing. So in the left facing, which planes we are going to use? We are going to use the x-axis and the y-axis. So on the xy plane, the basic shape of this rectangular face of this particular prism will be located, right? So we have drawn the ground horizontal line, x-axis and z-axis we have drawn at an angle of 30 degree. Now we are first of all interested in x-axis. So on the x-axis, 50 millimeter length will be drawn, 50 millimeter edge of the base, right? So this face will be facing the left hand side. So my front view will be looking from this side. This will give me the side view over there. So here my 50 millimeter edge will be there. Here my 40 millimeter edge of this rectangle is going to lie on the y-axis. This is the height. Now my height of the rectangle becomes 40 millimeter. And this rectangle, we have assumed that it is resting on one of its rectangular faces on the ground. So the rectangular faces we are going to take to be resting onto the ground. And this rectangle is resting on the longer edge on ground. So 50 millimeter. So 50 millimeter is our longer edge. So this is resting onto the ground over here. So that's why we have taken this edge length equal to 50 millimeter. Now you can check. This is 50 millimeter and this is 50 millimeter edge drawn on the x-axis, and this is 40 millimeter length which has been drawn onto the y-axis over here. So this is my y-axis. So once I draw these two isometric lines, so this isometric line corresponds to one of the edge of this particular rectangular face, and this will be parallel to y-axis on the isometric. Similarly, this edge, this is again parallel to the x-axis of the isometric axis of the isometric projections. Now we have been able to complete the left face, that is rectangle shape we have been able to obtain. So two edges, they are of 50 millimeter, and the remaining two edges they are of the 40 millimeter length over there. Now we are given that information that the length of the axis of this rectangular prism, it is 70 millimeter. So this length, please check, this is the length which is equal to 70 millimeter. Now I need to draw this length along the z axis. Now this is my z axis. Now from here I will be drawing 70 millimeter, right? So once I complete this face, now please check, 70 millimeter I have to draw. Now why I have darkened all these, you see, edges over here? Because I am looking from this side. The observer is looking from this side. So observer will be able to see all the four edges of this rectangular shape that we had drawn on the x y plane over there. So all the four edges, they have been darkened. Now this is the length of the axis over there. So I have drawn this length is equal to 70. Similarly, from here another isometric line 70 mm, and from here another isometric line 70 mm long will be drawn. So this is my 70 millimeter length of this particular prism, and again this has to be isometric length, not the true length. So this is again 70 millimeter, again 70 millimeter, and then you draw this vertical height, it is this edge, and finally you join the another edge of the top face. So all the edges of the top face, they are visible to the observer. Please check, all the edges of the top face, they are visible to the observer, but there are three edges we can see over here which are not visible to the observer. These three edges, two of them, they correspond to the back face, and one edge is corresponding to the base over here. So we can join them, and you can see, draw another vertical edge from the fourth corner over here, and once again the height will be 40 millimeter over here, and then draw this length equal to 50 millimeter, and this edge will be parallel to this and these isometric line. This edge will be parallel to this one and this one, that is y axis, and draw the third one, hidden one, it is this one, this will be parallel to the z axis. So now we can have the complete feel of this rectangular prism. Now we can find out the axis, front face as well as the back face, and once you join both of the center points, now this gives me the axis of the rectangular prism, which is resting on its rectangular face onto the ground, and it is facing the left side. So this gives me the front view, this gives me the side view, this gives me the top view of the rectangular prism. Now the last case for today, we are required to draw the isometric projections of a rectangular prism. Edge is given to us 50 by 40, and the length of this particular prism is given to us 70 millimeter. Now this should be right facing, so my front view will be this right face of this prism. So now once again we draw first of all the isometric scale, then the horizontal ground line we have drawn, and then x-axis and z-axis we have drawn at an angle of 30 degree each, and thereafter you see I have to draw the edge of 50 millimeter over here and 40 millimeter height. This will represent another edge of this rectangular face of this particular prism. So this is 40 millimeter height, and this along this distance along the z-axis, this should be 50 millimeter because it is resting on the ground with its longer edge onto the ground. So the longer edge 50 millimeter, it is resting onto the ground. So this edge will be 40 millimeter. So height of this prism is given to us as 40 millimeter. So I draw another isometric line corresponding to the fourth edge of this rectangular shape. So I have been able to obtain this rectangular face, which is the front face of this particular rectangular prism, and all these faces I can darken all the edges because the observer is going to look from this side. So observer will be able to have clear picture of all these four edges of this rectangular prism. Then the length of this particular prism will be drawn along the x-axis, and now I have drawn 70 millimeter length along the x-axis, and again I draw another edge 70 millimeter parallel to the isometric x-axis and another one over here, and then draw one edge vertical parallel to these two edges and draw one edge over here parallel to the z-axis. So this will complete my top face of this rectangular prism. So this construction of the rectangular prism is completed otherwise. So we have not shown any hidden edges. So in order to show the hidden edge, now I can draw one vertical edge equal to 40 millimeter length. This edge will be parallel to y-axis and these two edges as well. Similarly, I will draw this edge parallel to the z-axis. This is my z-axis, and this edge will be parallel to this one, and this one. And finally, this is another construction line I have drawn, which is drawn with 2H light pencil, and this edge will be parallel to this one, and this one, that is x-axis over there. So this completes the construction of all the edges of the prism, rectangular prism. Now I can find out the center points corresponding to the front face, center point corresponding to the back face, and then once you join these two center points, so you are able to obtain the axis of this particular prism. So with this 6 cases discussion, we have been able to learn about how do we go about the construction of isometric projections of square prism and the rectangular prism in all the 3 orientations. And we will be requiring these basic 6 cases while we are going to discuss about construction of isometric projections of the cylinder, construction of isometric projections of the cone, cylinder of the isometric projections of pentagonal pyramid, hexagonal pyramid, pentagonal prism and hexagonal prism. So these basic structures will be required. These 6 structures will be required while we are going to discuss about the basic construction of the isometric projections for different types of pentagonal and hexagonal prisms and pyramids, as well as cone and cylinder over there. So this basic discussion will be the fundamental so far as the construction of the other isometric projections of the solids it is concerned. So that is why we have picked up all these 6 cases in a single lecture. So this is all for today. So we'll be continuing with few more lecture discussions regarding the isometric projections of the solids in the coming lectures. So thank you very much. Thanks a lot.